The maximum peak-to-peak voltage of an AM wave is 16 millivolt and the minimum peak-to-peak voltage is 4 millivolt. Calculate the modulation factor. Okay. So from this question we can say that maximum peak-to-peak voltage is equal to 16 millivolt. Similarly, minimum peak to peak voltage is equal to 4 millivolt, which means that consider the amplitude wave. So we get an envelope. So this portion A, B. This portion AB represents minimum peak to peak voltage. Okay, so minimum peak to peak voltage is equal to AB. So AB represents minimum peak to peak voltage. Similarly, consider this figure C and D. The CD represents maximum peak to peak voltage. So our aim is to find out modulation index. One more point is that CD is equal to 2V max and AB is equal to 2V minimum. That is, consider the point O. It means that AB is equal to OA plus OB is equal to 4 millivolt. That is, minimum peak to peak voltage is equal to 4 millivolt. Therefore V minimum is equal to 4 millivolt divided by 2 is equal to 2 millivolt. Okay. Similarly, CD represents maximum peak to peak voltage is equal to 16 millivolt is equal to 2 Vmax. So this is Vmax. So CD is equal to CO prime plus O prime T. That is Vmax plus Vmax is equal to 2 Vmax is equal to 16 millivolt. Therefore, Vmax is equal to 16 millivolt divided by 2 is equal to 8 millivolt. Okay. Therefore, modulation index M is equal to V max minus V minimum divided by V max plus V minimum is equal to 8 millivolt minus 2 millivolt divided by 8 millivolt plus 2 millivolt is equal to 6 millivolt divided by 10 millivolt, which is equal to 0.6 is equal to 60%. Okay, very simple question. Okay, so similarly we can discuss about another question. Okay, so very simple question, so we can going to discuss about another question. Question is, a carrier wave of 100 volt and 1200 kilohertz is modulated by a 50 volt 1000 hertz sine wave signal. Find the modulation factor. Find the modulation factor. Okay, very simple question. So we can write modulation factor M is equal to ES divided by EC, where ES means amplitude of signal wave, AC means amplitude of carrier wave. It is simple condition. ES means amplitude of signal wave, EC means amplitude of carrier wave. Before going to solve this problem, I will show you what is EC and ES. Consider this is a sawtooth wave that represent a carrier wave, and plus this is signal wave. And this represent carrier wave. So we are getting an amplitude modulated wave like this. And this represents amplitude of carrier wave. And this portion represents amplitude of carrier wave. So from this figure, this portion represents EC. This portion represents EC. That means amplitude of carrier wave. And this portion represents M into EC. This portion represents M into EC. MEC is equal to ES. MEC is equal to ES. Therefore, we can write MES is equal to M into EC. So, M is equal to ES divided by EC. So, ES is equal to 50 volt divided by EC is equal to 100 volt is equal to 0.5. Is equal to 0.5. Very simple question. Then another question is that a sinusoidal carrier voltage of frequency. Next question. A sinusoidal carrier voltage of frequency 1 megahertz and amplitude 100 volt is amplitude modulated by a sinusoidal voltage of frequency 5 kilohertz, producing a 50% modulation. Calculate the frequency and amplitude of lower and upper sideband terms. So, solution. Frequency of carrier wave FC is equal to 1 megahertz is equal to 1000 kilohertz. Next point, frequency of signal Fs is equal to 5 kilohertz. From question, modulation factor or index M is equal to 50% is equal to 0.5. The frequency of carrier Fc is equal to 1 MHz. Similarly, we get amplitude of carrier wave EC is equal to 100 volt. EC is equal to 100 volt. So, what is the condition? Calculate frequency and amplitude of lower and upper sideband terms. So, lower sideband frequency is equal to Fc minus Fs. So 1000 kilohertz minus 5 kilohertz is equal to 995 kilohertz. Second one, upper sideband frequency is equal to Fc plus Fs. 1000 kilohertz plus 5 kilohertz is equal to 1005 kilohertz. Similarly, on next point, amplitude of each sideband is equal to M into AC divided by 2. 0.5 into 100 divided by 2 is equal to 25 volt. By applying this condition, this is Fc minus Fs, Fc plus Fs, lower sideband frequency, upper sideband frequency. So amplitude of lower sideband frequency is equal to M into EC divided by 2 is equal to 25 volt, and amplitude of upper sideband frequency equal to 100 volt is equal to EC, and this portion represent frequency and this portion represent amplitude. Okay, this is the basic condition for upper sideband frequency and lower sideband frequencies of amplitude modulation. The next question. Any wave is represented by the expression V is equal to 5 into 1 plus 0.6 cos 6280t sine 211 into 10 raised to 40 volts. What are the minimum and maximum amplitudes of the M wave, and what frequency components are contained in the modulated wave, and what is the amplitude of each components? So on this question we can write V is equal to 5 into 1 plus 0.6 cos 6280t sine 211 into 10 raised to 4 volts, which is exactly equal to inner equation V is equal to EC into 1 plus M cos omega st sin omega ct. Okay, so comparing this condition, EC is equal to 5 volt, M is equal to 0.6 volt, omega S is equal to 6280, and omega C is equal to 211 into 10 raised to 4 volt. Okay, so we can write EC is equal to 5 volt, M is equal to 0.6, omega S is equal to 6280. Therefore, Fs is equal to omega S divided by 2 pi. 6280 divided by 2 pi is equal to 1 kilohertz. And omega C is equal to 211 into 10 raised to 4. Therefore, Fc is equal to omega C divided by 2 pi 211 into 10 raised to 4 divided by 2 pi, which is equal to 336 kilohertz. Therefore, minimum amplitude of AM wave is equal to EC minus M into EC. 5 minus 0.6 into 5 is equal to 2 volt. And maximum amplitude of AM wave is equal to EC plus M into EC. 5 plus 0.6 into 5 is equal to 8 volt. And lower sideband frequency Fc minus Fs is equal to 336 minus 1 kilohertz is equal to 335 kilohertz. And upper sideband frequency is equal to Fc plus Fs is equal to 336 plus 1 kilohertz is equal to 3337 kilohertz. Then amplitude of lower sideband and upper sideband is equal to M into EC divided by 2. 0.6 into 5 divided by 2 is equal to 1.5 volt. So we can write the graph. Fc minus Fs, Fc plus Fs. Frequency, amplitude. This portion represents amplitude of EC, and this represents MEC divided by 2. Okay. If you have any doubt, please contact me. Anyway, thank you for your contribution.